Previous class we have seen what do you mean by serializability, right? So serializability is a kind of a property which is meant for to define whether a non-serializable schedule S dash is equivalent to a serial schedule S, right? So this one we can define in three ways. One is with respect to result serializability or result equivalent, or we can define in terms of the conflict operations, like the number of conflicts, like or the conflicts what are occurring in non-serializable schedule is equivalent to the conflicts what are occurring in serializable schedule. We can call it as conflict serializability, or we can define in another terminology called view serializability, right? So when we are saying that a non-serializable schedule S dash is equivalent to serial schedule S, means it has to follow three properties. What are those? If I am saying that a transaction Ti is performing read operation on the data item A, then in serial schedule also the same transaction number Ti has to perform read operation over it. This is the first statement. And the second thing is, if transaction Ti is performing final write operation on B, the same transaction Ti has to perform final write operation on B in the same in serial schedule also. And in addition to these two, one more point is there, that is if there exists any kind of write read conflict, for example Tj is reading certain data which was produced by Ti, right, in this particular kind of write read conflict, the same thing has to be happen in the serial schedule also, right? If I am assuming that this is serial non-serial schedule S dash and this is serial schedule S, so the same thing has to be happen here also. If it is going to satisfy all these three properties, I can call it as view serializability, right? So if you want to make it simplification process, the conflict serializability we can able to define with the help of a dependency graph, right? If I draw any kind of a dependency graph, if the graph contains a loops, I can call it as not conflict serializability. If there are no loops, I can call it as conflict serializability, right? Similarly, if I would like to define the shortcut procedure for view serializability, right, first and foremost important point is every conflict serializability is a kind of view serializability. Based on that, we can write. So first I will try to find out whether it is a conflict serializable or not. If it is conflict serializability, definitely it is a view serializability, right? For example, assume that it is not conflict serializable. Then we have gone through one more kind of procedure, that is whether it is having not blind writes or not. Whether it is having no blind writes or not. If there are no blind writes, I can directly say that it is not view serializability also, right? If these two cases are failed, meaning that if it is not conflict serializability and if it is having blind writes, then I have to go for again drawing the graph. In this graph, we have to check all the possibilities again, right? First possibility is who is performing the first read operation. If you want, you can go through the earlier statement, right? First, who is performing the first read operation and who is performing the first write operation of the same data item here, right? Then you have to draw the dependency between those two nodes, dependency between those two transactions, and then who is performing final write operation, and for this node we have to draw the dependencies from each and every transaction. This is what you have to do. And in the third step, you have to find out various kind of write read conflict dependencies, right? Once you draw the graph with respect to these three statements, again if it contains any kind of a loops, I can call it as not view serializability. If there are no loops, it is a kind of view serializability. But here the point is, you should not consider them directly. You have to come up with this particular position. Okay, so this is what we have seen in the earlier class, right? And also, if you remember, we have started with the concept of scheduling, right? So what is the reason we are starting with the concept of schedule? Because earlier to this concept, we have started with like execution of various kind of transaction. The execution can be again like serial execution, or it can be a kind of concurrent execution. If it is a kind of serial execution, there is no problem with the database consistency, right? Meaning that your database is always going to be in a consistent manner. But when you are going to work with the concurrent transactions, or I can say in another manner as interleave transaction, there is a certain situations where your database might be in an inconsistent mode. Right? Even it is going to produce an inconsistent mode, we are trying to make it to correct into the consistent mode, right? Meaning that we cannot say that all kind of concurrent transactions are not going to produce inconsistency only, but there are certain kind of concurrent transactions which may produce consistent state also. For that reason, we are trying to check all those kind of transactions, right? So in order to check those transactions, we are moving for the concept of serializability, right? So if you thought that if it is going to be equivalent to in terms of view, or in terms of conflict, or in terms of result, then I can say that which is equivalent to a serial schedule and which will provide more server utilization. Am I right? All kind of concurrent transactions are going to behave more server utilization instead of having the serial schedules, right? Yes. So the problem with concurrent transactions is they are going to behave some kind of thing like inconsistent mode. To overcome this drawback, we are going to make them into consistent mode by making certain kind of arrangement, right? All kind of transactions which are going to produce some inconsistent results, if you are going to set them in proper order, meaning that if you are going to schedule them in some order, I can get some kind of consistency also. That's the reason we moved for the concept of schedules, right? Where you have come across the concept of serial schedule, where a transaction T1 completes, then only will move for transaction T2. If T2 completes, then only will move for transaction T3. This is what serial schedule. Coming to non-serial schedule, here it is not going to depend on upon the every transaction, other transaction. It is going to execute when it is having enough space, right? So simply you can say that interleave transaction will be called as non-serial schedule. Again, this non-serial schedule will be classified as serializability, non-serializability, right? Serializability is a kind of a property which is meant for to define whether a particular non-serializable schedule is equivalent to serial schedule or not. For that, we have seen the serializability property. Now in today's class, we'll see further various kind of non-serializability schedules, right? What is the meaning of non-serializability schedules, right? So obviously the basic property of non-serial schedules are a kind of concurrent transactions. Is it concurrent schedules? Yes, they are concurrent schedules because they comes under non-serial schedules, right? As they are going to be executed, they are going to be sometimes produce an inconsistent database also, right? So based on this, again they classified it into two types, which you have seen earlier only, right? One is a kind of non-recoverable schedules, another type is a kind of recoverable schedules, right? So in what terminology they have classified means, if you are able to observe, if take any kind of database, when I am going to perform certain kind of operation on this particular database, certain situations on the concurrent transactions, it may produce into inconsistent mode. If your schedule always going to produce an inconsistent state when there is a failure, then that kind of schedule I can call it as non-recoverable schedule. I hope you understood clearly, right? Meaning that basically the database certain times may be failure, right? When a failure is going to be happen, certain situations it may lead to inconsistent state. That kind of schedule of transactions I can call it as non-recoverable schedules. Right? In what situations it might get? For example, if you are able to clearly understood the transaction T1 and transaction T2, T1 and T2. For example, I am trying to perform the read operation of A and write operation of A. Write operation of A, and I am trying to perform once again read operation of A and again write operation of A. And then immediately I am going to perform some kind of commit operation. Later, I am trying to perform once again commit operation for the transaction T1. Now this will becomes under a kind of non-recoverable schedule. Why means, if you are able to observe this example, initially it has read the value of A, it has updated certain value of A. Suppose for example A equal to A plus 500. I think this was seen earlier, A equal to A plus 500. And after performing write operation of A, that was handed over to T2. Now T2 perform the read operation of A. Again it is trying to perform something like A equal to A plus something like 200. Again it performs write of A. Then it did commit operation. After that, it comes to this point. Before this point, here at this point of time, if some failure happened, what the database is going to do? Database is going to perform some kind of rollback operation. Once it did the rollback operation, what will happen to the database? Here this data is going to be lost. First thing, this data is going to be lost. Yes, but in the real world, is this data is going to be really lost? What is the meaning of commit operation? Commit means even at any kind of situation, it cannot able to roll back. Commit means it's permanent save, right? Even as myself as a database, I am trying to roll back, I cannot able to get back this, right? But with respect to transaction T1, if it is going to have initial value of 1000, at this point of time, the value of A will be 1500. But once you perform the rollback, it has to get it to 1000. So with respect to transaction T1, it should be the consistent state. Means the 1000 is consistent. But can it going to be the rollback? It cannot able to possible. That's the reason this is what we call it as non-recoverable schedule. Right? Why you got this non-recoverable schedule? Because if you are able to clearly observe, when some transaction Tj reading the value which is updated by some other transaction Ti, it is some other transaction Ti, and Tj is committing before the commits of Ti. The non-recoverable schedule is going to be happen. We cannot able to recover to the consistent state. This is what we called as non-recoverable schedule. Right? So this kind of situations, there is a chance of occurring. You have to handle all those things. Right? So simply the definition is, when Tj is reading the value updated by Ti, Tj committed before commits of Ti, I can call it as non-recoverable schedule. Okay, now, right? So this kind of schedule we can call it as irrecoverable schedule also. Irrecoverable schedule, right? So I think I have given one example, right? So basically, when you are in exam hall, your friend have written the exam, right, with some kind of bit paper. The another friend has copied the same bit paper, right? So once he has copied, right, meaning that he is trying to update the data from which is written by his friend, and he has updated his also. Now before submitting the actual person, he has submitted to the emulator. Later, the actual person tries to modify, or he thought that there are certain kind of mistakes. He tried to modify. At the time, what will happen? The person who has copied is going to get wrong marks. Right? This is going to be irrecoverable, right? Meaning that he cannot able to get back the actual marks. Right? This example clearly defines the non-recoverable schedule. Right? So in other classification, they have classified as recoverable schedules. Means what? when you are trying to perform some kind of read operation or some kind of write operation, you must and should have to take care of whether they have first committed or not. Right? In other terminology, if I say, if a transaction Ti, if a transaction T1 and a transaction T2 are the two transactions are performing some operation, something like as per earlier example only, read of A, write of A, read of A and write of A. Write of A. What they are saying, if you would like to make your transaction should be in a recoverable mode, whatever the transactions that are dependent, those commits should be done before, those commits should be done after commit of the independent transaction. If you are able to observe this particular example, right? T1 is independent, right? In this particular scenario, T1 is independent because after read of A in T1, after write of A T1, then only T2 is going to perform its operations, right? Now, with respect to this situation, T2 is dependent transaction on T1, T1 is independent transaction. So, if you would like to implement any kind of recoverable schedule, so dependent transactions commit should be done after the independent transactions only, right? Now, with this particular scenario, for example, all the transactions are done here and here. If there is any commit, if there is any failure here, then what you can do? We can able to simply roll back. If you are going to roll back, as we haven't used any kind of commit operation in the T2 also, every data is going to get back to the old state. This is what we called as recoverable schedule, right? If you are able to observe the definition, Tj reading the value, updated or writing some other transaction Ti, right? Meaning that if I assume this is Ti and this is Tj, Tj is reading a value or writing a value which is updated by some other transaction called Ti, then commit of Tj must occur after the commit of Ti only. This is what we called as recoverable schedule. You may get the question here, sir, can I write the commit here? Can I write it? I can write it anywhere, there is no problem. But the point is, before committing the Tj, definitely you have to commit, that's it. So the order of commit can be varied, right? So based on the order of commit, you are trying to use, it will be classified again into three types. One is cascade recoverable schedule, another one is cascadeless recoverable schedule, another one is strict recoverable schedule. Okay, I hope you understood this point clearly, right? So the way you are trying to take the commit in the independent transaction, depending on that, it classified as into different types, right? Now I hope you understood this is a kind of a recoverable schedule. Okay, now if we take the cascading schedule, if I take the transaction T1 and the transaction T2, transaction T1 and transaction T2, if I take the transaction T1 and transaction T2, read of X, write of X, here also read of X and write of X. Assume that I have a transaction T3, read of X and write of X, right? Now, to make this as a recoverable schedule, where can I place the commit? Right? T3 is dependent completely on T2. So can I make commit at the end? Right? Now I can make the T2 commit here. I can make the T1 commit here. Is it a recoverable schedule? Yes. Right? It is a recoverable schedule, and also I can call it as a cascading schedule also. Because what the cascading schedule means, if I am saying that a transaction T1 is going to be failure, that failure is going to be rollback of all other transactions, right? As I am trying to roll back the T1, whatever the dependent transactions are there, right? T2 is dependent, so whatever the operations that are done by T2 is going to be rolled back, whatever transactions that are done by T3 are going to be rolled back. Am I right or not? Why the T2 and T3 are going to be rolled back? because the database has to be kept into the consistent mode. To make your database into consistent mode, they roll back of all the dependent transactions also. This is what we called as cascading schedule, right? So simply a failure of one transaction will lead to rollback or abort of all other dependent transactions. All other dependent transactions, I can call it as cascading schedule, right? If you are able to observe, T2 is dependent on T1, T3 dependent on T2, right? For example, T2 only perform, like for example, commit done here successfully. At this point of time, if there is a failure, then failure of this particular transaction is going to lead to rollback of only T3, not T1, right? This is what we called as cascading schedule. Okay, fine. So what might be the problem in this particular situation? If I am going to have n transactions, as all n transactions having the commit at the last statement, all transactions has to be rolled back, right? That's a problem, right? To overcome the drawback, we are moving for another kind of schedule we called as cascadeless schedule, right? So in cascadeless schedule, what we are going to do means, if I am going to have transaction T1 and transaction T2, if I am going to have the read operation of A, write operation of A, and if I am going to do some kind of write operation, there is no problem, right? But if I am going to perform some kind of read operation, this read operation has to be done when the commit has to be done by the other transaction. This is what we called as cascadeless schedule. In cascading schedule, if some rollback happened, all are going to be rollback. Whereas coming to cascadeless schedule, we are not going to roll back all other dependent transactions, because if I are able to clearly observe, if something like, if I try to take once again completely write of A, again some kind of commit, again commit, is it comes under recoverable schedule? Is it a recoverable schedule or not? Yes, it is recoverable schedule, because if you take the dependent like operations, they are going to be committed before the commit operation of T2. So I can call it definitely it is a recoverable schedule. But can I call it as cascading schedule? No, because for example, if it is going to be happen the failure at this point of time, if this failure is going to be affected to the T2, it is not going to affect it for entire transaction, but maybe for up to the part of the transaction, right? So I can call it as cascading schedule. So by what sense we are not going to roll back all the entire transaction? Because when a particular transaction Tj reads the value which was updated by some other transaction Ti, then commit of Ti must done before reading of Tj, right? If I are able to observe this example, as I am trying to read the value here from the transaction which was produced by T1, its commit is done before the transaction T2 only, then I can call it as cascadeless schedule, right? It's a kind of simple definition. Okay, so this is a kind of cascadeless schedule, but here we didn't discuss about any kind of write operation. I think you may got idea, right? We didn't discuss about any kind of write operation. We are always trying to define out with respect to only read operation. Whereas coming to strict schedule is going to add more stricter rules, right? So means it is going to include not only about read operation, it is going to include write operation also, right? So means if I take the transaction T1 and transaction T2, if I am trying to perform the read operation of A and write operation of A, write operation of A, basically if I write like here commit, okay, this is a kind of a commit. Now guys, can I call this as a kind of recoverable schedule? Can I call it as a recoverable schedule? Obviously, because R of A and write of A are going to depend on T1 and its commit is done before committing the T2 only, right? So T1 done commit, then we got it to T2. So I can call it as recoverable schedule. Can I call it as cascadeless schedule? Yes, cascadeless. I can call it as cascadeless schedule. Why I can call it as cascadeless schedule? Because read operation it is performing. This read operation is done once the commit done by other transaction. So I can call it as cascadeless schedule also. Right? I cannot call it as cascading schedule. Right? Okay, done. Cascadeless. And if you take the earlier example, can I call this as now strict schedule? No, because if you are able to observe, as transaction T2 is trying to perform write operation, which was updated by already T1, right? But in cascadeless schedule, it is going to be updated. It is going to be updated. But if you take the strict schedule, what they are saying now, even it is going to be a write operation, you should not allow that, right? That's the reason they are calling it as strict schedule. So here you have to think about write operation also, right? If you are going to add here write of A, it won't be comes under strict schedule. It is not strict schedule, right? As I have eliminated this one, it will be comes under strict schedule. Strict schedule, meaning that it is going to be more stricter. That's it, right? If you read the definition here, transaction Tj precedes a conflict of operation. Precedes a conflict of operation Ta, right? If I say this is Tj and this is Ti, right? Transaction Tj precedes a conflict operation Ti. Conflict operation might be what, ma? Write read, write write, read write, right? If you observe any kind of this situation, then commit or abort of Tj also preceded the conflict operation of Ta, right? So meaning that before like going for the further process of Tj, you must should have to perform commit operation. This is the meaning of strict schedule. It is more stricter than the cascadeless schedule, right? Guys, tell me, is this a kind of strict schedule? T1 followed by T2, R1 of A, R2 of A, R2 of A. Now, is it a strict schedule? Is it a strict schedule? No. Right? What is the kind of definition? Only you have to think about conflict operations. Is there any conflict operations? Even though they are on the same data item between the different transactions, they are not going to be conflict operations. So I can call it as strict schedule. Right? So when we can say that it is not strict schedule, if this particular rule is going to be violated, then only I can say it is not strict schedule. And all the remaining operations are going to be comes under strict schedule. Okay, na? So if you are able to observe clearly, if I say, right, if I say strict schedule is having more stricter rules than cascadeless schedule. Yes or no? It is having more stricter rules than the cascadeless schedule. And cascadeless schedule having more stricter than cascading schedule. Yes or no? And cascading schedule is having more stricter than recoverable schedules. Recoverable schedule, right? Means if I define the relation between all these things, if I say it is a kind of a strict schedule, every strict schedule will be a cascade schedule, cascadeless schedule. Am I right? Every strict schedule is going to be a cascadeless schedule, right? Every cascadeless schedule is going to be a cascading schedule. Okay, na? And all will becomes under, you can draw a round exact circle, you can be called as recoverable schedules, and irrecoverable schedules are separate from the recoverable schedule, right? This is a like something like Venn diagram for the relationship between various kind of recoverable schedules. Is it correct? Yes, it is perfect, right? So means every strict schedule will be a cascadeless schedule, but vice versa is not correct again, right? Why vice versa is not correct? If you take this example itself, right? It is cascadeless, but not strict schedule. The strict schedule is not happening because of this write operation is done before committing its operation, right? So with this example, I can say that this is the corresponding diagram for it.